Hello everybody, my name is Niloufar Shahdoust. I'm a master's student at University of Tehran. Today in this tutorial, I'm going to help you with better understanding the concept of overfitting and generalization. Overfitting happens when our model would learn too much of the details or even noises of our trained data, and this would negatively impact the performance of our model on new data set. And the solution to this problem would be regularization, which minimizes the complexity of our model. Here, let's take a look at the code. Here we're going to import our data, which consists of behavioral and neural data of a mouse doing some kind of task. And the goal of this regression analysis would be investigating whether the neural activity of a mouse is explained by its behavior. Here we're going to separate our train and test data on different chunks. The reason that we have chosen chunks is that we know that neural points are correlated in time, but we want our train and test set to be as independent as possible. Here we're going to implement linear regression, and then we're going to compare it with ridge regression, which uses regularization. Here in the first line, we're going to matrix multiply our train set with itself in order to find a covariance matrix of our trained data. And here we're going to find covariance matrix between trained data and our neural data, which can be our labels here. And here we're going to use the solve routine, which takes the first input, finds the inverse of it, and multiply it by the second input. Here we have that we have the matrix of weights. We can find the prediction of our model, and here we have found the variance explained across principal components. Let's see how our model works. Good. Here we have in green we have our predictions, and here in black we have our ground truth of the test. And but take a look at here. As we see, we have explained only 25% of variance with our first PC, which is not a good number. And here in higher order PCs, we can see that we have negative variance, which means that we have added variance to our data set, which is not a good thing. We can solve this problem by ridge regression. In ridge regression, we add a regularization term, and lambda is regularization parameter that controls the string of this regularization term. And here we are going to implement all of these, and all of these is going to be the same, except for that the lambda would be 10 to the power of 6, and we are going to we are going to create an identity matrix by creating an identity matrix with the shape of our train data in here. Okay, let's just implement it and see the results. And as we see, yes, here we have explained the 50% of variance with our first PC, which is a really good number, and this is a really big progression in here, sorry. And we're going to compare the linear regression to ridge regression here. And as we see on the left, we have the fit to the first PC for the trained data, and as we can see, the linear regression is more closely to ground truth of our data, which is not a good thing. It shows that linear regression overfits the data. And here on the right, we can see that the fraction of variance explained in the test data is better in ridge regression.